Okay, so let's talk about forces. First question, what is force? Right, I'm pretty sure you have some experience with the forces. You apply forces all the time, right? When you pick something, when you move something, you're applying forces on it. So the question is, what is a force? Anybody? What is the definition of a force? It's the change of speed applied to an object. The change of speed is basically acceleration. So he's trying to relate forces with the acceleration. And of course, you always have some inertia in the object, so that plays a role too. Heavier the object is, less acceleration it will have, right? We all understand that. So what he's talking about is, force is equal to mass times acceleration, right? Any other definitions?
It's something that either causes or restricts movement of an object.
It causes or restricts the movement of an object, sure enough. That's a good way of putting it qualitatively. Any other definition of the force? Sorry? Amount of work being done? Not quite so. Amount of work being done is a different quantity altogether. Work has a different unit, has a different dimension. It is related to the force, but it is not exactly the work done, right? You will learn pretty soon that work is defined as a dot product between force and the displacement, which often simplifies to force times displacement, as long as both of them are in the same direction, but not in general. So how many of you think that the definition of the force is mass times acceleration? And don't be afraid to raise your hand. It's okay. I won't judge you guys. So if you think force is mass times acceleration, raise your hand. No, it's okay. Yeah. So that's what I thought. Most of you probably think that definition of the force is mass times acceleration. Well, actually, that's not really true. You may have learned that definition maybe in your high school physics classes, but definition of the force is not mass times acceleration. Force equal to mass times acceleration is a relationship. Okay? That relationship does not define what a force is. Just as you are not defined by your relationship with your parents, or your relationship with your friends, or with your girlfriend, or anybody else in the world, right? You are who you are. So if I said, hey, tell me your name, Brian, define yourself. How would you define yourself?
Just by who I am. I don't
know. Who you are, right? Will you say, hey, I'm defined by my parents are Mr. John Galt and Mrs. Galt, yeah, something like that. How would you define yourself? Anybody? How would you define yourself? Tell me your name. Hasla. Hasla, how would you define yourself?
I talk about myself, different characteristics.
Okay, you'll talk about yourself, different characteristics. Okay, that's good. Vincent, how would you define yourself? Vincent, just by the name. But that doesn't tell me much, right? I mean, you could be Mr. X. Would it tell me anything if you just told me the name? So you guys are right. You can't define something by the relationship. It has to have an intrinsic definition for something, right? So force have to have an intrinsic definition. Could be defined by the characteristics, right? Could be defined by the interaction, but it is not defined by a relationship. So F equal to ma, which is the Newton's second law, I'm sure most of you know, is not the definition for the force. So what is a force? Well, force, we all know qualitatively, is a push or a pull, right? Certain things can be pushed, certain things can be pulled. If you take a rope, you can pull the rope, but can you push the rope? You can, right? So you can apply the tensile load on it, but you can't apply compressive load on it. So certain things can be pushed, certain things can be pulled, and they're all characterizing an interaction, right? So that's qualitatively put, but that doesn't define what a force is. So definition of force is variable. There is no single universal definition for force. Definition of the force depends on the material interaction, because force is nothing but an interaction between two objects. Now, the definition of the force will depend on what is the nature of that interaction. So let's say I talk about myself. Okay, I'm standing here. What is my interaction with the floor of this classroom? So I'm pushing down on the floor, right? I'm pushing down on the floor. If this floor was made of a very weak material, I probably would go down, right? Because I would apply a lot of load on the floor. So I'm pushing down on the floor, right? What is floor doing on me? It's pushing me up. So force is pushing me. That's what you were going to say, right? So force is pushing me up. So that's my interaction with the floor. Am I interacting with anything else in this world? Air? Why am I here? Why am I not flying? So the gravitational pull of the Earth is pulling me down, right? It's pulling me down. So my interaction with the gravitational system of the Earth is of one kind of interaction, is one kind of force, and that's the gravitational force. So it's pulling me down. So gravity is a kind of force. Now, if let's say I was walking, I would be interacting with the floor in another way too. So it's supporting me at the same time I need friction to walk, right? So that's another interaction. Now, what is that force? What is that friction force? What would it depend on? What is its value? So interaction will define what the force is. If I took, let's say, maybe there was a spring over here, or maybe an exercise equipment with a spring on it, and I was pulling on it, I'll be applying a force on the spring. So my interaction with the spring would be such that I will be pulling the string, I'll be pulling the spring, and the spring will be pulling me in the opposite direction. But then the question is, what is the force on the spring? And that depends on what that interaction is. So definition of the force depends on the nature of the interaction, which means it has to be a variable one, right? So as long as if you don't know the nature of the interaction, you cannot tell what the definition is. But force is never defined by this relationship. Okay? That's the thing that you need to remember from today's lecture. Because when you get to dynamics, I will ask this question again. Okay, so force is a vector quantity, right? Which means that we can resolve it along x and y direction as long as the force is in the xy plane, and I will be able to write something like this. By the way, this is a cartoon that one of the Mech 101 students from this class drew last year for me. I hired her. She's a great illustrator, so I hired her to do some of the drawings for my class. So you'll see some of these pencil sketches drawn by her, and it's quite amazing that a mechanical engineering student is able to do this kind of sketching. I really liked her sketches. Okay. And that girl, by the way, looks a little bit like her. So you can probably, find out who she is.